Okay, so the next question asks us to find a basis for the null space of A. Okay, we know how to do this. All we have to do is write the augmentation where A, B, C, D are all 0, and then solve for all the solutions, and then, do a little factoring so we kind of write out in vector parametric form, and that'll give us our answers. So over here, all this is going to be zeros, and if we were to write out all the solutions, we've got a lot of variables. Okay, we've got x1, x2, x3, x4, and x5, and x6. Okay, this is our big solution vector. Now, our free variables, let's go ahead and write them out first. I guess I'm going to use, instead of A, B, C, and D, I'll use X, Y, and Z. So our first free variable is this second guy. So there we go. It's an X. Our next free variable is the fourth guy. Let's make that a Y. And then our next free variable is the fifth guy, so I'm going to make him a Z. Okay. Now we have to write out our other variables in terms of those variables. So x6, he's pretty easy. He's just 0, because over here, this right column is going to be all zeros. Now, our x3, what's he going to be? He's going to be a minus x4 and a minus x5. So it's going to be minus x minus y. So minus x minus y. I shouldn't have made this so small. That's okay. Now, our x1 is going to be a minus 2x2 minus 3x4 minus 2x5. So I'm going to have, it's going to be very small, minus 2x, and then a minus 3y, and then a minus 2z. Oof, that's really ugly. Sorry about that. I'll maybe put a dot, dot, dot right there. Help express what's going on there. You should, of course, write this better on your exam, but hopefully you know what I mean here. Next, what we're going to do is let's factor out our parameters and break it up into different variables. So everything that involves an x, let's do that one first. All right, so everything that involves an x is this minus 2 here, and then we have a 1 there, and we're going to have a, oops, this shouldn't, oh no. Yeah, this, oops, I made a mistake here. Let's go ahead and correct that. Uh-oh. This shouldn't have been a y, this shouldn't have been a minus x and a minus y, this should have been a minus y and a minus z. Let's just fix that real quick. Okay. Minus y minus z, right? Because our x3 variable, that is this guy here, is in terms of x4 and x5, right? Which are these two variables. So now that's going to go away. So we have 0, a 0, a 0, and a 0. Great. So now let's write out the next one. Everything that involves a y. We're going to have a minus 3 up top, 0 here, a minus 1 here, a 1 here, a 0, and a 0. And then everything that involves a z. All right, this is going to be a minus 2 here, a 0 here, a minus 1, a 0, a 1, and a 0. So this gives us that our basis, which I'll call maybe beta, we can write out as these three vectors, minus 2, 1, 0, 0, 0, 0. And minus 3, 0, minus 1, 1, 0, 0. And the next one, which is going to be minus 2, 0, minus 1, 0, 1, 0. Great. So this is a basis for the null space of A. You might want to do a reality check, make sure you have the right number of vectors in there. Since the rank of our matrix was equal to 3, and we have 6 columns here, we know that the number of vectors in a basis for the null space has to be 6 minus 3, which is 3, and we got the right number there. Great. So the next question that we have is to find the affine space, which is exactly a set of vectors such that this is true. Now, this word affine space here is a bit of a red herring. All you're doing is just finding all the solutions to this system here. And the affine space, that's just saying that it is an affine space. So all we have to do is write out the solutions to this system in vector parametric form. And to do that, well, all we'd have to do is put this vector here, 3, 5, minus 2, 4, on the right-hand side of this augmentation. And then we would do some row reduction over here and read off our solutions from that. So instead of doing the row reduction, we can just plug in. So we can get that minus a plus c plus d, a minus d, minus a plus 2d, and a plus b minus 2d. We just have to figure out what these guys are, and then we can write out our solutions. So in this first guy, we're going to have a minus 3 plus minus 2, that's minus 5, plus 4, so we're going to get a minus 1. And in this one, we're going to get a minus 1, and this guy, we're going to get a 5, and this guy, we're going to get a 0. This is actually the same arithmetic that we did before. So I'm just going to write it all down here. Now, if we put this guy on the right-hand side of this, and we were to read off all the solutions and write them out in vector parametric form, this is what we would get. Let's write out x1, x2, x3, x4, and x5. Oh, also x6. Lots of vectors. Okay. So now if this were over here on this right-hand side, maybe I'll write this down again so we can see what we're working with. 1, 2, 0, 3, 2, 0, 0, 0, 1, 1, 1, 0, 0, 0, 0, 0, 0, 1, and then a bunch of zeros. Augmented by minus 1, 5, and 0. Right. This is what we're working with now. Okay, if we were to write down the solutions there, how would we do it? Well, let's not make the same mistake we did last time and make this too small. Over here, we're going to get a minus 1. Oops. No. Let me erase that. I was just blindly copying things down. Okay. Let's go ahead and read off the solutions. We start off by assigning our free variables to parameters. Like last time, we can use x, y, and z. So over here, x2 is going to be our friend x. x4 and x5 are going to be y and z. And now we assign values to our other variables based on our parameters and what's over here. So x6, he's easy. He's just 5. Voila, he's just 5. And now our x3 is going to be a minus 1, minus y, minus z. Didn't make that same mistake I made last time. So we have, this is going to give us our minus y, this is going to give us our minus z. And now x1 is going to be minus 1 for this one right here. And then we're going to get minus 2x and minus 3y and minus 2z. Ooh, that's a very big vector. But there it is. And now we can go ahead and factor it out like we did with the null space stuff. What are we going to get? Hey, we're going to get minus 1, 0, minus 1, 0, 0, 5. And then we're going to add on our x stuff. And this is going to be our minus 2, 1, 0, 0, 0, 0. Then we're going to add on our y stuff. This is going to be minus 3, 0, minus 1, 1, 0, 0. And then we're going to add on our z stuff. And this is going to be minus 2 and 0, minus 1, 0, 1, 0. Okay, and that's it. These are this part over here. Okay. The set of all vectors like this is the span of these three vectors. Or really it's the null space. This is a vector space, and this is a single solution to the system. So this is expressing our solution as a vector space plus some vector, which is what an affine space looks like. That's that one. And I think we have one more part to this question, which is as follows. Find a basis for the row space of A. This one's really easy. A basis for the row space of A consists of all of the vectors in the non-zero rows of our reduced row echelon form. So we can go ahead and write this out. Let's say, I'll call it C. No, I'll call it B again. B, which equals, and we could write this as columns or rows. I guess I'll write them as columns. So 1, 2, 0, 3, 2, 0. 0, 0, 1, 1, 1, 0. And 0, 0, 0, 0, 0, 1. Okay. This is a basis for the row space of A as they are the non-zero rows in the reduced row echelon form of A. Okay, I guess technically transposed I should put here, but that's fine. Transposed. Okay. So that's it for question number 9, and that's the last question on our midterm. So if you have any questions on this question or comments, please put them in the comments below or ask in class. Thank you very much.